Work today. That's awesome. All right, here's what the logistic growth curve looks like, and it's really handy to know the curve, because if you know its shape, you can answer a lot of questions that way. So what's going on is there is some limiting, there's a limiting factor. There's it's called a carrying capacity. Carrying capacity. For any environment. And we're going to start off with a certain population. I'm going to start here. This is our initial population right here. This is, we're going to call this P for population. It's real creative, right? It starts at some value. And what's going to happen is it's going to grow exponentially at first until it starts running out of resources. And then the population will stabilize at a population, certain population. So when they introduced wolves back into Yellowstone, they introduced a small pairs of wolves in a small population. Well, at first there was all this. There were all the prey animals because they hadn't had wolves there in forever because they got hunted to extinction, right? Well, at first there's plenty of resources, and then as their population grows exponentially, eventually they got where they don't have enough food, and so now it's more competitive, and it sort of stabilizes the population. They can't support an unlimited number of pups, right? And then they start dying off a little sooner. So basically, any environment has a sustaining population. Yes.
Is that like a hard line, or it can fluctuate?
It can fluctuate. I was going to get that. This is the perfect curve. In reality, what happens is it goes a bit above, and then it corrects and goes under, and then it goes a little above, and eventually, when it's real stable, there's very small undulations in a real population. But the mathematics behind it has it approaching. That's a limit. That's a limiting value. So the mathematics looks like that. In reality, the populations we are modeling tend to cross it. So you have to remember, horizontal asymptotes can be crossed, vertical cannot. This is a horizontal asymptote, so it can go back and forth. But it usually corrects, and it gets closer and closer to it with time as it stabilizes. Assuming it stabilizes. Now there's a whole lot of other things going on, like when they had the fire in Yellowstone, that kind of wiped out everything. So in a perfect system, there's no perfect system. But it's a model. Remember that? Okay, looking at this. The limit as time goes to infinity. By the way, this is time. And we are going to infinity. What is my population going to go to? Just looking at the graph. It goes to L. It's a limit. So with this kind of question, are they going to pull back stuff from the curve sketching unit? Yes, they're going to ask you curve sketching questions. Oh, and look, I have concave up and concave down. I have an inflection point right here. Can they ask me curve sketching questions? They can. But for logistic growth, every single time, this is concave up, this is concave down. This means the second derivative equals 0 because I went from positive to negative, right? That's an inflection point. And what does that inflection point mean? For our population, because think about it, if P of T is how many wolves we have in Yellowstone, then the slope of this curve, is that slope, is that dP dt? So that's the rate. So what does this inflection point tell you? The rate went from increasing to decreasing, right? And does that mean that that's the maximum rate? Because it was increasing and then now it's decreasing. Does everyone see that? The slope was increasing and then my slope was decreasing. So at that inflection point, it means that that is the max dP dt, which the other way of looking at it is it's a max growth rate. because my second derivative is equal to 0. Okay, there are words that go with this. And it was a funny thing in my review session last night. There's a whole section where he just makes us translate the words into a differential equation, and then makes us solve it using all sorts of interesting methods that we're learning in the chapter. Which means I have to really go, oh, which one's this one? Anyway, the whole point is there are a lot of people that can't translate word problems. So we did the words that describe Newton's law of cooling, right? We're going to do the words that describe logistic growth, because I'm going to give you a word problem and you're going to have to write the differential equation and solve it at least once. You're going to have to solve Newton's law of cooling from words. You're going to have to solve a logistic from words, at least partway. Okay? All right. So how do we write this? Here is what the words would look like. It would be something like the change in population with time is proportional to both P and the carrying capacity minus P. Now there are two approaches on logistic growth. There are two versions of the equation. And the funny thing is, the version that I was using last night on my homework is the other one, of course. But I like this one because it makes sense that it's proportional to both the P and the L minus P. To me, it does make sense anyway. All right, so we have to translate that into an equation. Okay, what is change in population? Huh? Say it again? Okay, so it's dp dt, right? So let's write this. I'm going to color code it. The red is dp dt. Change in population with time. Does that make sense? Is just equal sign, right? I can just do that for is. Proportional to. Proportional means the K. Okay? Nobody got it. All right, both. That means it's P times L minus P. It's proportional to both means multiply them. And we just took that sentence and we turned it into a differential equation. Is that a derivative equation? Can we separate the variables and integrate it? Absolutely. Everything with a P goes over on this other side, right? So I end up with the integral of 1 over P L minus P dP equals the integral of K dt. Remember, K is a constant. A proportionality constant. Have you learned anything recently where if you had the denominator factored, you could bust that thing up and actually integrate it? Because you notice there's nothing up top. So the derivative of P times L minus P is not there. You cannot use U sub. Do y'all see that? Did we learn anything recently where I can take that thing with a sledgehammer and bust it up? What would it be? Partial fractions. Oh, snap. Is that why we had to learn that? Uh-huh. So we could do this. So what this is going to become, so I know I got to do this, so I'm going to go off and do my algebra first. So for my algebra, I'm going to say that 1 over P times L minus P is equal to A over P plus B over L minus P. Is this a really easy one? It's the easiest logistic growth, easiest partial fraction. So conceivably, I could test you on partial fractions by doing one of these. And I don't have to do two problems. So you should probably make sure you know how to do this. All right, does this mean that 1 equals A times L minus P plus B times P if I get a common denominator? What did I do? I went L minus P over L minus P, and this was P over p, right? And now I have a common denominator. If you don't need to show this and you can go straight there, you can go straight there. Just don't mess up. Because if I don't see anything up there, I can't give you any partial credit, right? So don't screw it up. Okay, what am I going to choose? How am I going to choose wisely? Because I have to choose wisely, don't I? Choose wisely. Choose a p, 0. So p equals 0. When p equals 0, is the b going to go away? Yeah? So what do I end up with? I get 1 equals, and if I put in 0 for this, will it just be a times L? And so what does a equal? 1 over L. And I'm just going to tell you that this is true every single flippin' time. Once you've done it once, it never changes. It's always this. For this particular form of the equation. There's another form, but don't worry about that. Okay, what else am I going to choose? P equal to what? L. If I choose P equal L, does the A term go away? And I get 1 equals BL. Oh, look, what does B equal? 1 over L. Do they each will equal 1 over L? Isn't that convenient? That really helps our cause, because what does our equation become? It becomes the integral of 1 over L, 1 over P, plus 1 over L minus P, dP equals, what's the integral of K dt? KT plus C. Are these two things going to be natural logs? They are, aren't they? Okay, so what I'm going to do is I'm going to take this, I'm going to copy it and go to another page because I'm out of room already. Copy. Oh, I didn't do this. That's okay. I'll fix it in a minute. Look how good I am to get this now. Yeah. Okay, here we go. So, we know that this is going to be 1 over L, natural log, absolute value of P, minus natural log, absolute value of L minus P, equals KT plus C, and can I combine those? I can. Can I go ahead and get the L, rid of the L by putting it on the other side, by multiplying by it?
It should be close. Yeah, it should be close.
Yeah. Plus, sorry, plus. No, minus, y'all are wrong. What's the derivative of L minus P?
Negative P.
Oh, tricky, aren't I? I can look at that and do that. If you can't, do you need to go off to the side and go, okay, if you need to do this, go off to the side and go U equals L minus P, du equals negative dP, and that's where my negative sign came from. Oh. I'll repeat, I don't need U sub as often. I do use U sub occasionally. When it gets really messy, and I've changed variables too many times, which I have to do in my differential class, then I use U sub. Boy, do I use U sub. So I keep some stuff straight sometimes. Okay, now we're going to multiply by the L. So we're going to multiply the whole darn thing by L, and then I'm going to combine those two, because I want to get rid of the natural log really desperately. Is that why I've been trying to get y'all to do log properties the whole flipping year? It's for this problem, because y'all are not going to get anywhere in solving it unless you can do this, log properties. So what's left over here, this becomes natural log, oh, let me change colors. Natural log, absolute value of P divided by L minus P, right? Equals KLT plus, well, K times C is just C, right? KC, can I just, that's C1, can I just call this C2? That's K times C1. Huh?
L.
Oh, it's L, but anyway, sorry, it doesn't matter, it's still a constant, L. Is that just a constant? So we're just going to call it C. Right? All right, not done yet. How do I undo this? I'm going to do exponential. This whole thing raised the e power, this whole thing raised the e power, and do you have to watch this because you're adding it? Does this become e to the KLT times e to the c, which means it's c. We're not going to call it c. We're actually going to change this. We're going to call it b. You'll see why in a minute. It's going to be b, because I don't want you to confuse this with exponential growth when we get to it. b e to the KLT. Ooh, that's cool. And what's on the other side? P over L minus P. That's like way cool. We're almost there, but we're not there yet. Because I really want to solve for P, and I can't do it in this form. I just can't. So I need to do some multiplying and get things on the other side and all that stuff, right? That's correct. That's what I need to do. So I'm just going to multiply by L minus P to the other side. Actually, no, I'm not. I have another way to do this. I have a very clever way to do this. Hold on to your hats, children. I want to get L minus P by itself, so I want it on top. So can I just say this is over 1? No, I'm going to flip both fractions. So this is B1. I'm about to make a different B. Watch this. So I'm going to say that this is L minus P over P is equal to my new B, which is 1 over B, e to the negative KLT. Multiply by the P, I get L minus P equals P times B e to the negative KLT. Can I get all the B's on one side? I'm going to move the B over here and keep the L over here. So I get L equals, my professor did not go this slow for me. Last night he was flying. Whew! I have scribbles. So L is equal to P plus P B e to the negative KLT. Factor out a P. Do you get P times 1 plus e to the negative KLT? Did I factor out a P? Excuse me? Oops, I left off my B, thank you. B's right here. I got distracted. Thank you. All right, can I solve for P now? Can I just divide that by that? Does P of T equal L over 1 plus B e to the negative KLT? Now the version my professor was using was another version of this, but every time I was working the problem, I immediately got down to this one because it's the one I'm used to. Plus it's easier. I've got a 1 there. I like the 1. The 1's nice. He has other stuff there. It's a pain in the butt. But however you want to look at it, is that the equation for logistic growth? Does it have our carrying capacity in it? Yup, it does, twice. There and there. And then, like we did yesterday for Newton's law of cooling, do we use an initial value to go find that K, that proportionality constant? And then we do another point to find the B, which is just our coefficient. Are y'all ready? Here we go. Let's see if I have enough I don't have enough room to do an example. Let's find another page. Here we go. I want to see if I can fix this and make it, move it. I want to move it. Move. I want to move. Never mind. That's not what I want to move. Okay. Well, I'll rearrange the pages afterwards. Here we go. So we're going to do our example 1. And that's probably all we're going to get to because it is activity schedule. And this stuff takes time for y'all to write down. In this example, it's the spread of the flu at CCHS. Yeah, coronavirus, but we'll say it's coronavirus this time. In T days is modeled by, and this is the kind of modeling I do. Yeah. dp dt. They are giving it to us. I could say this in words, but right now to expedite it, am I going to just give the equation instead of say, I could state all of this in words, couldn't I? I could, but right now we need to speed up. Okay, this is saying that the carrying capacity is 3,000, that the proportionality constant, that's what this is, that's the proportionality constant, proportional to, right? What is another way to write this? Is that 1 over 1,000? How do I know it's 1 over 1,000? Because it's 3 decimal places. Ones, tens, thousands, right? It's 1/1000th. They're going to tell us that our initial population, the initial number of people who are infected with the coronavirus, did I say that right?
Yeah.
Coronis or corona? Coronavirus is 50. We got 50 students sick with it. Okay, that's our conditions. And the first question they want to ask us is, okay, if we give this coronavirus an infinite amount of time, how many people are going to get infected under perfect conditions? Everybody. Everybody's going to get this puppy. Now we're not talking about who's going to die off. That's another problem. That's a whole nother. That's a whole nother problem. But eventually, if we go an infinite number of time and nobody skips school because they don't want to get sick, and we don't do anything about it, we let the sick kids come to school, will everybody get it? That's all that's saying. But they put on the AP test because they can say they did a limit. And that is a boundary condition. I mean, that's like in behavior, it's curve sketching. They just love bringing back stuff, right? Next thing, they want you to solve for P of T. And when I say solve for, you have to do the calculus. If I just say what is P of T, if you memorize the formula, you can just do that. And you can use it. If I only want to know, well, how long will it take for a certain number of people to become infected, or how many people will be infected in 10 days, you can just use the formula. But if I ask you to solve for P of T, it means start with the derivative. So here we go, darlings. We're going to plug everything in. We didn't quite finish, right? We got to finish this problem. This doesn't quite look like what we did, does it? It's close. Can we separate the variables? We can. Should we rewrite this a little bit? So let's start back here. I got my differential equation. dp dt equals, and the k is, it's 1 over 1,000 p, right? That's what we had, times 3,000 minus p. And I would really like to get rid of that 1,000, wouldn't I? We can. You could leave it there and then integrate it, and you're going to have to deal with it for flipping forever. But instead, can we move it to the other side? Do you like 1/1000, or would you prefer 1,000? I prefer 1,000. So can we flip everything? Can we go 1,000 divided by p times 3,000 minus p? I'm going to integrate that with respect to p is equal to the integral of dt. See what I did? All I did was put that over there because the 0.001 doesn't work for y'all or me. What's the integral of dt? T plus c, right? For this one, am I going to do my whole partial fraction thing? So what I'm going to say is that because I know that 1,000 over p times 3,000 minus p is equal to a over p plus b over 3,000 minus p. And what did we get a minute ago when we did this? Did we get a was 1 over L and b was 1 over L? And if you happen to remember that, can you go ahead and start writing that? You can. You can. But I want to simplify that. I got 1,000 on top, and I'm going to show you how I can simplify this really fast. So what I'm saying is 1,000 is equal to A times 3,000 minus P plus B times P. And I'm going to tell you that instead of the being 1 over L, it's going to be this. So I'm going to factor out that 1,000 and it's going to end up being 1/3 when you simplify it. You'll get there. All right, so what am I going to choose for my P, the first one? 0. And then what's my other one going to be? P equals 3,000. If I pick 0, B goes away. And if B goes away, then I have 1,000 equals 3,000 A. And what does A equal? 1 over L, which is 1 over, this is not 1 over L, this is, yeah, 1/3. And it's because of the 1,000 with the K. It works out nicely. For this one, if I pick 3,000, A goes to 0, the A term goes to 0, I have 1,000 equals B times 3,000, and you still get 1/3. Right? Everybody see that? Isn't that cool? We're just working with what we got. And we didn't worry about what the formula said. We just did it. Now, that means we got to integrate 1/3 integral of 1 over P dP plus 1/3 integral 1 over 3,000. Why did I write it separately? For those who forget that minus P, sometimes it might help you write it like this. If you write it like this, will it be a hint that this might be different? You probably need to fix that, right? And for those that have trouble with this, you're going to go U is equal to 3,000 minus P, so du equals negative dP. And that's why y'all lose negative signs, because you don't pay attention. So I'm going to go to the next page. And I now have, I get to 1/3 natural log absolute value of P minus 1/3 natural log absolute value of 3,000 minus P equals T plus C. Combine those. Am I going to get 1/3? Oh, I can move that to the other side, right? I can just multiply by 3. What?
Why is there not a constant when you take the integral of the partial fraction?
Because we would collect it all on one side.
So you just,
We're just collecting all the constants to the left. We just put them all on the left.
alright, so you just assume that C is,
It's in collecting all of them. And since you're going to solve for it in the end, it doesn't matter what you do. You don't want to do it in the interim steps. Too complicated. Save it all to the end. Just collect all the C's on the... C just stands there. I'm collecting all the constants. You can call it whatever letter you want, but I'm still collecting. And anything I do that's just adding, subtracting, multiplying, or dividing by another constant is still C. Still constant. All right, so this becomes, I'm going to multiply both sides by 3, and then I'm going to get natural log. That's messy. Come on, today. Oh, why is it not responding? You're being weird. Hang on. I'm letting it reattach itself. There we go. Whew. Some days it just is persnickety. Absolute value of P over 3,000 minus P is equal to 3T plus 3C, which is still just C, right? Agreed? It's just a C. Who cares if it's multiplied by 3? How do I undo this? Exponential. Is it really important that you be able to do this? Which is just e to the 3t times e to the c. Am I going to expect to see that step in your work? If I don't, I'll take off. Because it's a common mistake if you just go too fast. So that just becomes a new constant. We're going to call that b. Maybe we'll call it b. We're going to call it b. We changed. All right, so where am I at? I am to p over 3,000 minus P, that's 3,000, not sixes, minus P is equal to some constant B e to the 3t. I could have left it C, it doesn't really matter. Does it? Nope. Flip things. Why? Because I want to get this by itself. So I got 3,000 minus P equals over P equals, so it's a new B, just it's 1 over the last B, e to the negative 3t. Did I flip both fractions? I did. Multiply by P, I get 3,000 minus P equals P B e to the negative 3t. Put all the p's on one side. P plus PB e to the negative 3t. Still with me? We're going to factor out a P. P is 1 times 1 plus B e to the negative 3t, right? And can I solve for P now? So my P is equal to 3,000 over 1 plus B e to the negative 3t. That's your logistic growth equation. Now, do we have to use what we were given? We have to find the B, right? So we're going to use P of 0. P of 0 was 50. 50 equals 3,000. Messy, messy, messy. Here we go better. Over 1 plus B e to the 0. Is that going to go to 1? So it's 3,000 just equal to 1 plus B. Multiply both sides by it. Do I get 50 times 1 plus B equals 3,000? See why I like this one, because it's just algebra. What are we going to divide by? 50. So I get 1 plus B equals, well, what? Okay, just ignore the zeros. So it's going to be 60, right? And then does that mean that B is equal to 59 because it's 60 minus 1? Can we write our equation now? This is what we were trying to find in A. Just in A. P of T equals 3,000 over 1 plus 59 e to the negative 3t. Huh? What do I mean B?
Because B is solid for P.
Huh? What are you babbling about?
You did, like, this was.
Oh, did I do part B?
That's supposed to be part B.
I thought we were talking about the big B that I just, oh, too many letters. Too easy to get lost. But is that what we were trying to find? Let me go looking back. I got, like, after all that, I can't even remember what question I asked y'all. Yes, that was the right one. And then you would use it. Because after you did that, now can we use it if we had to? We could use it if we had to. Now, looking at that whole thing, could we figure out when the population was growing at the greatest rate? Because that's part C. I didn't write it down yet. May I go to a new page? Okay, so what if they ask you in part C, what is the population? And they're asking, what is the population? They're not asking when. What is the population? When it is the virus spreading the fastest. Which is when the population of people who are infected is growing the fastest. Right? Okay, remember the curve. It looks like this. This is when the second derivative equals 0, and that is when the rate of growth is the fastest. Is that what I want? I want to know the population when it is spreading the fastest. So what do I need to do? second derivative. So let's write down what the first derivative was. Remember, way back when we started all this, it's going to be, what was it, 3,000? Oh, let's go find it. Where's our derivative? Oh, there it is right there. Can I distribute that very easily? We're going to distribute that. So hang on a second. Let me grab this. We'll grab what we had, and we'll go from there. I'm going to erase this. Maybe. I'm going to paste. Uh-oh. That's not what I meant to do. Undo. Let's go down here and tap on here and paste. There we go. I much prefer that. I can move it now. That works for me, right? That was our equation. That's not a very nice form of it. So we're going to distribute the 1,000, right? Correct? So I'm going to distribute the p. So I get, because you don't want to do product rule, do you? Do some algebra instead. Multiply this times each term. Watch what happens. Yeah? So we're going to end up with 3p, because 3,000 divided by 1,000 is 3, right? Minus p squared over 1,000. Is that going to be easy to integrate or take a derivative of? Sorry, take a derivative. We're not solving this one. It's another way to solve, but. All right, for this one, so if we want to take a derivative, we want the second derivative with respect to time. What's the derivative of 3p? With respect to time. Is it chain rule? OMG, did y'all see that coming? It's implicit. I'm taking it with respect to time. Did y'all notice that? With respect to time. So it's 3 dp dt, yes? Minus 2p dp dt, and this is all over 1,000, yes? OMG. Okay, do we have to put in what dp dt was? We do, right? We have to put it in there. So this is going to equal 3 times 3p minus p squared over 1,000 minus 2. Okay, can I change that to 1 over 500? Is that okay? Can I just say this is p over 500? Times 3p minus p squared over 1,000. Don't distribute. I'm about to show you some math magic. Does everybody see that? I substitute in. I want to know when this equals 0. Do I need to factor this? Are these the same factor? Can I factor that out of each one of them? So watch what I'm going to do. I'm going to say that this is equal to oh, wait a second. What did I do?
Wouldn't it just be 0? You just do 3 minus p over 500 equals 0?
Hang on a second. Oh, I'm going to factor a p out. I'm going to factor that p out too. So if I factor this, first off, is there a p? And then is there a 3 minus p over 1,000? Are those both factors? And then what's left over for this term, let me do it this way. This 3 and this are left over, so it's 3 minus p over 500. Right? Are those all my zeros? There are 3 zeros. 2 of them don't matter. 2 of them are endpoints. This is when population is 0, right? That's not realistic because I started with 50 people, so that one's not going to help me any. That's not useful. And then the other one, this one is when p is equal to 3,000. That's also limit capacity. That's carrying capacity. I know that's not right. That's not what I'm looking for, right? It's true. It makes the equation true, but that's not what we're looking for. If we want to know when it's growing the fastest, right? Is it probably there? Probably. So we should try that. We should go 3 minus p over 500 equals 0. That means 3 is equal to P over 500, which means that P is equal to 3 times 500, which equals 1,500. Did you know that there was half of the carrying capacity? Let me give you a hint. It's always like that.
Is it always half?
It's always. Always. Yeah. So, that's a problem. If I make you do the calculus. If I don't make you do the calculus, if I don't make you solve for P of T, if I don't say those magic words, I just say, use the equation, then you just have to know the equation to use it. But I promise you that on my test, I'm not going to do that. You're going to have to, that's right, solve for P of T. Do you need to practice it? That's a lot. Are you going to have to practice it? Yes, you are.